Hello, my fellow animal lovers. How are you today? Before I ferry you to dreamland, if you love the content and you love animals, I encourage you to show your support by subscribing. By the way, tell us where you are in the world in the comments section. What time do you like watching our channel? I look forward to reading all your comments. Enjoy. Chapter 1 Beneath the Gentle Earth, a Hidden World Awakens. As the soft light of dusk begins its gentle descent, painting the world above with hues of amber and rose, or perhaps as the first faint hints of dawn begin to stir, breathing a new vibrancy into the forest, the canopy above settles into a quiet rhythm. A subtle rustle of leaves, a distant, almost imperceptible hum of unseen life, whispers through the air, signaling the preparation for slumber or the slow stirring awake of the diurnal world. Yet, beneath this familiar surface, where the gnarled roots intertwine with the rich, dark soil, a different, profound rhythm holds sway. Here, far from the sun's direct gaze, lies a realm of perpetual twilight and gentle, unceasing industry. It is a world cloaked in mystery, where life flourishes in a constant, calm hum, a stark contrast to the often frenzied pace of the world above. This is the hidden domain of the leafcutter ant, a truly remarkable architect of the natural world, frequently glimpsed in the sun-dappled rainforests and tropical forest edges of Central and South America, extending even into parts of the southern United States. These tiny, diligent creatures are often observed parading pieces of vibrant green leaves held high like miniature parasols across the forest floor. Indeed, their iconic image, resembling an endless procession of small mobile umbrellas, has earned them the endearing moniker of parasol ants. They are known not for their speed or their sound, but for their tireless, persistent nature, a quiet dedication to a purpose far grander than their individual forms suggest, embodying an advanced form of social organization and sustainable agriculture. Gently, the focus shifts downwards, past the tangled roots and the cool, damp earth, to the unseen world where their true work unfolds. It is a world carved with patient precision, a sprawling network of quiet activity, a testament to collective patient effort that hums with an inherent, calm efficiency. These are not mere nests. They are often described as large underground metropolises or supercities, intricate empires built into the very fabric of the earth. Imagine cities hidden from human sight, vast and complex, yet operating with a profound sense of tranquility, a continuous flow of quiet, purposeful labor. The sheer scale of these subterranean realms is truly remarkable, yet it is a grandeur expressed in quiet terms. A single mature colony, particularly of the Atta genus, can house up to 8 million members, with some records indicating populations reaching even 10 million ants. This bustling populace thrives in harmony beneath the ground, supported by a colossal infrastructure. Their homes are not small burrows, but expansive networks containing thousands of chambers, each sometimes 30 centimeters or more in diameter. Collectively, these underground cities can span an area from 30 to 600 square meters. These elaborate structures can reach astonishing depths of 4 meters, or even up to 7.6 meters, with some accounts mentioning depths of up to 9 meters. The central mounds of these nests, visible above ground, can grow to 30 meters across in just a few years, with smaller radiating mounds extending outward up to 80 meters. The sheer volume of excavated soil can be immense, with colonies of Attosextans estimated to turn over 40,000 kilograms of soil in tropical moist forests, a process that even stimulates root growth in many plant species. This immense scale, often hidden from human view, speaks to a profound, quiet grandeur. It is not a loud, imposing structure, but a vast, intricate network built with tireless, gentle effort, a testament to the quiet power of collective endeavor. This hidden world operates with an inherent, calm efficiency, a stark contrast to the often frenzied pace of the world above, inviting a sense of peaceful awe. This vastness is managed with precise control, a quiet mastery over their subterranean home, a world built by countless tiny, deliberate movements, each contributing to the serene continuity of the whole. Some chambers within these subterranean cities are so vast that a central chamber in a large colony can be big enough for an adult human to stand inside. This deep connection to the earth and their quiet, persistent transformation of it showcases them as true ecological engineers, shaping their rainforest environment in significant ways. Chapter 2: Architects of the Deep, the Slow Dance of Excavation. Beneath the quiet surface, the leafcutter ants engage in a patient, rhythmic work, a slow dance with the earth itself, a continuous ballet of meticulous excavation. They are the true architects of the deep, their movements deliberate and precise, shaping the very ground into a living home, not unlike master sculptors crafting a magnificent work from raw stone. With an innate wisdom, honed over millions of years of evolution, they choose their foundations carefully, preferring well-drained, deep sandy soils for their excavations. This meticulous selection ensures the stability and longevity of their subterranean cities, preventing catastrophic collapses and providing the necessary consistent conditions for their delicate fungus gardens. The importance of this soil preference is underscored by the fact that if they choose poorly, such as near human-made structures or unstable areas like roads, their extensive excavations can even lead to sinkholes large enough to swallow vehicles, a testament to the immense volume of earth they displace. The primary excavators are often the medium-sized workers, their forms perfectly suited for the demanding task of sculpting the earth with their specialized mandibles and limbs. These tireless individuals construct the intricate tunnels and chambers that form the labyrinthine pathways of their metropolis, a network of corridors and rooms that can extend for vast distances and depths. The process of digging is a delicate art, far from a haphazard scramble or a frenzied chaos. Soil is not merely removed. Instead, it is carefully aggregated into pellets by a gentle raking motion, meticulously performed using their mandibles and front legs. This transforms loose, unmanageable soil into a cohesive, transportable form. Sometimes with surprising grace and precision, they pull the material together with closed mandibles in the manner of an ice cream scoop, a perfectly adapted action that creates uniform spherical masses. These perfectly formed pellets are then quietly transported away from the excavation site, carried by tiny, strong legs through the dark, winding tunnels, each journey a quiet contribution to the growing architecture of their hidden world. The tunnels themselves can extend up to 70 meters long, connecting chambers that vary in size and depth. Some chambers can be as shallow as 7.0 centimeters, while others reach over 70 centimeters deep, with the highest frequency of chambers typically found within the first 5 to 10 centimeters of depth, where conditions are optimal for initial fungus garden development. The quietness of this work is profound, a hushed symphony of industry. It is not a loud, disruptive process, but a continuous, gentle modification of the earth, a steady, persistent reshaping of their world, unfolding in near silence. Within this silent industry, a subtle form of communication takes place, a testament to their intricate social coordination that transcends audible shouts or calls. As ants dig, they stridulate, producing a quiet, high-pitched squeaking noise by rubbing specialized body parts together to attract nestmates to excavate at the same location. This delicate vibration is transmitted through the soil itself, a silent call for shared effort, a gentle invitation that draws others to the task, ensuring harmony and efficiency in the dark, confined spaces. This quiet language of cooperation transforms individual effort into a synchronized, gentle dance of earth moving, a testament to their profound collective intelligence, allowing for seamless shifts and coordination in their subterranean endeavors. The vibrations ripple through the soil, a silent instruction that brings more workers to a specific task, maximizing efficiency and speed where needed. The colony also possesses an innate, quiet wisdom, demonstrating a deep understanding of the Earth's rhythms and the dangers it presents. A remarkable adaptation is observed in their digging behavior. Ants will stop digging approximately 12 millimeters below the interface between soil and water. This precise cessation of digging is a quiet foresight, a profound understanding of the potential for water inflow that field colonies might face in seasonally flooded soils, which could drown their precious fungus gardens and entire colony. The clay soil, while dry and hard in the absence of rain, swells and becomes soft and plastic after wetting, making it workable for excavation, but also posing a significant flooding risk. Their quiet cessation of digging at a certain depth is a testament to their deep intuitive connection to their environment, ensuring the safety and gentle continuity of the colony. This is not a frantic escape from danger, but a calm, inherent understanding of the Earth's boundaries, ensuring the colony's gentle continuity and long-term stability. This demonstrates a deep, nonverbal wisdom embedded in their very being, a tranquil assurance in their subterranean world, where every excavation, every pause, is a deliberate act of survival and collective well-being. This meticulous behavior highlights their ability to perceive and respond to subtle environmental cues, maintaining the integrity of their hidden city even against the unpredictable forces of nature, a silent promise of persistence. Chapter 3: The Breath of the Colony. Air, whispers, and unseen paths. Deep within the earth, where the fungus gardens thrive, a delicate balance of air is constantly maintained, a testament to the leafcutter ants' sophisticated environmental engineering. This is no simple task, as both the living fungus, which is metabolically active, and the countless ants themselves consume oxygen and produce carbon dioxide in significant amounts. This biological activity makes efficient ventilation an absolute necessity for survival. To sustain life and ensure the health of their precious fungus, the ants must precisely control the CO2 concentration within their chambers, actively working to avoid hypercapnic conditions, where carbon dioxide levels become dangerously high and toxic. This is a quiet, continuous act of environmental management, a subtle, ongoing engineering feat that ensures the delicate balance of their hidden world. Without this precise regulation, high CO2 levels would not only suffocate the ants, but also severely inhibit the growth of their symbiotic fungus, jeopardizing the colony's sole food source and ultimately leading to its demise. The ants achieve this masterful control by meticulously modifying the soil structure around them, creating an intricate internal architectural system of tunnels and chambers that facilitates gas exchange and circulation. This unseen network of pathways allows the gentle, unseen current of air to flow, a vital breath for the entire metropolis. This system is far more than a simple collection of randomly dug holes. It is a complex, three-dimensional array designed with an intuitive understanding of fluid dynamics to maximize airflow. They often cleverly utilize convection currents generated by natural temperature differences between the deeper parts of the nest, which tend to be warmer due to metabolic activity, and the cooler surface. The architecture even includes specific design elements to optimize airflow. Narrower tunnels might act as chimneys, creating differential pressures that draw fresh air in from lower openings and expel stale CO2-rich air out from higher ones. Within these subterranean homes, temperature and humidity are precisely controlled, creating an ideal, stable environment for their precious fungus gardens. The fungus typically requires a consistent temperature between 23 poser and 26 Pe, 73.4 Vef and 78.8 Vef, and a high relative humidity, ideally close to 100%, to flourish. This makes the ants masters of microclimate management, constantly fine-tuning their environment. One of their most visible adaptations for this sophisticated climate control is the construction of ventilation turrets built on top of central nest openings. These are not just decorative mounds, but highly functional structures, quietly enhancing air movement by elevating tunnel openings to catch the subtle breezes above the ground. The design of these turrets is remarkably responsive and dynamic. Studies have shown that elevated CO2 levels within the nest specifically lead to the construction of turrets with several minor openings and a larger total aperture. This is a subtle, responsive adjustment to the colony's internal breath, ensuring the gentle removal of excess gases and the continuous flow of fresh air, demonstrating a remarkable feedback loop between the colony's physiological needs and its architectural response. Furthermore, the ants even plug the central nest holes with soil and vegetative debris to regulate temperature and humidity, a quiet daily ritual of climate control, like opening and closing windows in a human dwelling. This behavior is particularly observed during the hottest parts of the day in summer, when ants might remain underground and seal off openings to prevent overheating or excessive moisture loss from the fungus gardens. Conversely, during cooler periods or when higher ventilation is needed, these plugs are meticulously removed, allowing for greater air exchange. This continuous, gentle management ensures the stability and peace of the underground world, highlighting the profound intelligence embedded in their collective behavior, a wondrous example of natural engineering. The colony, through its architecture and the quiet actions of its workers, functions as a vast self-regulating organism, a living climate system. The turrets are its subtle lungs, responding to its internal needs, while the plugging of holes is a quiet act of environmental stewardship, all contributing to a peaceful, thriving subterranean existence. This meticulous control of their abiotic environment underscores their deep evolutionary connection to their subterranean lifestyle and their profound ability to create and maintain optimal conditions for their singular food source, the fungus garden. Chapter 4: A Tapestry of Subtle Senses. Communication in Darkness. In the perpetual darkness of their underground world, where sunlight is a distant memory and light rarely penetrates, the ants experience a rich, hidden symphony of touch and scent. Their world is perceived not primarily by sight, which is of little use in the complete darkness of the nest, but through a tapestry of subtle senses, making the darkness not empty and void, but rich with intricate information. Ants constantly converse with one another using pheromones, sound and vibration, a hidden language that permeates their subterranean world, creating a complex and highly coordinated society without the need for visual cues. This constant flow of information ensures that millions of individuals can work together seamlessly, maintaining the intricate functions of the metropolis. Their antennae, described as long, flexible appendages packed with sensory organs, delicately detect chemicals, movement, and vibrations, serving as their primary guides in the dark. These highly sensitive instruments, constantly tapping and exploring their surroundings, allow them to discern not only the mere presence of sense, but also their direction and intensity, crucial for communication and navigation within the labyrinthine nest. Pheromones, as chemical signals, are truly the unseen whispers of the colony. These complex chemical compounds are released from specialized glands on an ant's body and detected by the antenna of its nestmates. They serve a multitude of purposes, meticulously marking foraging trails that can stretch for hundreds of feet, defining the precise boundaries of their vast territory, indicating the health or specific status of individual ants or the colony as a whole, warning of danger and alerting others to threats, and even guiding nestmates to newly discovered resources or suitable sites for expansion of the colony. These fragrant pathways create a silent, yet undeniably potent, language of scent, shaping the movements and behaviors of millions of individuals with subtle precision, ensuring a unified purpose. Furthermore, the tiny hairs or setae located on their bodies are exquisitely sensitive to touch and vibrations, allowing them to navigate through the dark or tight spaces where their sight is of little use. These microscopic hairs detect subtle changes in air currents, minute ground vibrations, and direct contact with other ants or the tunnel walls, collectively painting a detailed tactile picture of their surroundings. This sensory input is crucial for individual ants to move efficiently through tunnels, avoid collisions in crowded pathways, and maintain their position within the intricate network. Beyond simple navigation, substrate-borne vibrations play a vital role in coordination, serving as a form of silent communication. Ants can drum their bodies or mandibles against surfaces within the nest, generating rhythmic pulses that travel through the earth. The subtle time of arrival delays at legs allow other ants to precisely pinpoint the source of the vibration, guiding them to specific locations. This can be used to recruit nestmates for specific tasks, like excavation, signaling a need for help, or alerting them to potential threats in a particular area. This silent song of earth, a delicate vibration, acts as a quiet call to action, transforming individual efforts into synchronized collective endeavors. It serves as a hidden compass of touch, guiding them through their vast, sunless empire with unerring accuracy. Even though their primary mode of perception is not visual, leafcutter ants do possess simple eyes capable of low-light vision. These compound eyes, while not forming detailed images like human eyes, are primarily used for detecting changes in light, such as the time of day, and sensing movement, indicating threats or opportunities. When they venture above ground, this provides a faint glimmer, allowing them to discern the general shifts between day and night and recognize large moving shadows that might indicate a predator, a rival colony, or a newly fallen leaf. This profound, quiet connection binds the colony together as pheromones trace unseen paths and vibrations ripple through the earth, a language of stillness that allows for perfect coordination in their unseen world. It is a testament to the incredible adaptive power of nature, transforming perceived limitations into a rich and nuanced sensory experience, ensuring the calm, efficient continuity of the colony's tireless work in their deep, dark realm, a masterpiece of non-visual intelligence. Chapter 5: The Living Tapestry, Cultivating the Fungus Garden. At the very core of the leafcutter ant metropolis lies its beating heart, the luminous, living fungus gardens. These meticulously cultivated masses of mycelium are unequivocally the true source of food for the colony, a nutritionally rich resource that provides the sole sustenance, fueling their quiet industry. More than just a food supply, these gardens represent the extreme interiority of leafcutter being, a sacred protected space, a vital core, all but completely quarantined from the exterior atmosphere. This is a quiet, inviolable principle of their existence, a sanctuary where life flourishes in perfect harmony, shielded from external fluctuations, predatory molds, and contaminants that could devastate their delicate crop. The ambient temperature and humidity within these chambers are precisely regulated to provide the optimal microclimate for the fungus, reflecting an astounding level of environmental control. What makes this even more wondrous is the singular nature of this specific fungus. The species Leucoagaricus gongylophorus, or other closely related species within the family Lepiotacea, can only be found in their colonies. This is not a fungus they simply stumbled upon. It is a unique creation of their ancient partnership, a testament to millions of years of shared history and coevolution. This fungus has evolved such a profound dependency on the ants that it cannot survive independently in the wild. Its very existence is intertwined with their care, showcasing an unparalleled level of mutualistic adaptation. Its spores do not disperse naturally. Instead, the fungus is propagated by the queens, who carry a small pellet of the fungus in a special pouch during their nuptial flight to start a new garden. The relationship between the ants and their cultivated fungus is a profound obligate mutualism, a symbiotic relationship where neither ant nor fungus can survive without the other. It is a perfect, quiet interdependence, a dance of life woven over countless generations, a biological marvel of reciprocal benefit. The ants provide the raw material, fresh vegetation, a meticulously controlled environment, the nest chambers, and constant diligent care, weeding, grooming, and defense against pathogens, while the fungus, in turn, processes the otherwise indigestible plant matter into a highly nutritious food source for the ants. Indeed, the ants are often referred to as ancient farmers, having cultivated this fungus for millions of years, a practice that began 50 million years before humankind began farming. This deep history imbues their work with a timeless, profound quality, a quiet legacy of agricultural innovation that predates human civilization by epochs. Their methods embody sustainable farming principles, including composting, pest control, and specialized labor. This partnership is a beautiful example of coevolution, where both species have reciprocally adapted to each other, shaping each other's destinies in the dark through a quiet, continuous dance of interdependence. The ants have developed specialized mandibles for cutting and processing leaves, complex social castes for all farming duties, and sophisticated chemical defenses against competing molds and bacteria. Meanwhile, the fungus has evolved to efficiently digest diverse plant materials, produce specialized nutritional bodies tailored for the ants, and even develop resistance to ant-borne diseases. This ancient symbiosis is more than just a food chain, it's a quiet alchemy of shared existence, a timeless bond woven over millions of years. The ants provide the raw material and a perfectly protected home, and the fungus, in turn, transforms it into life-sustaining energy, providing essential amino acids, lipids, and carbohydrates that ants cannot synthesize themselves. This profound interdependence speaks to a deep natural harmony, a gentle continuous cycle of giving and receiving, a quiet testament to life's cooperative spirit, thriving in the unseen depths of the earth, an enduring example of biological perfection. Chapter 6: The Gardener's Gentle Care. Weeding and Sustenance. The ants' tending of the fungus garden is a meticulous, continuous cycle of care, a testament to their unwavering dedication as the original cultivators of the planet. It begins with feeding. Tireless forager ants bring a diverse array of plant material, primarily freshly cut leaves, but also flowers, seeds, and even oats to the nest. These fragments can be derived from hundreds of different plant species, though leaf cutters are remarkably selective, often preferring woody species and freshly sprouted leaves, flowers, and shoots, avoiding plants that produce harmful secondary metabolites. Once inside the nest, smaller workers take over, meticulously shredding the pieces into a fine pulp, a process that can take hours for a single leaf fragment. To this finely processed substrate, they add tiny droplets of feces, which contain enzymes that help break down the tough plant material, making it more digestible for the fungus, and also provide a crucial source of nitrogen, a vital nutrient for fungal growth. This mixture is then carefully shaped into perfect spherical masses, forming the foundation of the new garden and ensuring maximum surface area for fungal colonization. Finally, even smaller workers, the most delicate of the castes, with the utmost precision, plant the substrate mass with fungal hyphae, carefully nurturing their crop as if placing precious seeds in fertile soil. This prepared material becomes the fungus's dinner, the nourishment it needs to thrive, a continuous supply, ensuring the vitality of the entire colony. The fungus itself is a marvel of adaptation, exhibiting what is known as metabolic flexibility. It quietly adapts its enzymes to efficiently digest a wide range of different plant materials, preferentially breaking down simpler carbon sources when they are available, demonstrating an intelligent and efficient use of resources. This is a silent, intelligent adaptation within the garden, ensuring the most efficient nutrient extraction from whatever the ants provide, maximizing the caloric yield from their diverse botanical harvests. This flexibility is crucial for the colony's resilience, as the availability of specific plant matter can fluctuate seasonally or geographically, requiring the fungus to adapt its digestive processes. Beyond feeding, the ants are vigilant gardeners, meticulously tending to their mutualistic fungus, ensuring its pristine health and preventing contamination. Their care extends to rigorous grooming and weeding. They constantly groom contaminated body areas with their legs and mandibles and carefully lick contaminated garden areas, removing any impurities, spores of harmful molds, or bacterial growths that might harm their precious crop. This constant cleaning prevents the proliferation of harmful molds or bacteria, particularly specialized parasitic fungi like Escavopsis that could otherwise destroy the delicate fungus garden, which represents the entire food supply of the colony. To further protect their gardens, the ants even produce antimicrobial secretions from their metapleural glands located on their thorax. This quiet chemical guardianship acts as a powerful antibiotic, a complex cocktail of chemicals specifically designed to prevent harmful microbial growth and protect the fungus from diseases. This constant, gentle tending creates a profound sense of peace and order, a continuous dance of life and sustenance, maintaining the sterile environment essential for the fungus to flourish, a testament to their ancient agricultural prowess. In return for this tireless care, the fungus provides specialized hyphal swellings called gongylophorus, tiny perfect parcels of nourishment which the ants gently feed on. These gongylophorus are rich in lipids and carbohydrates, serving as the primary food source for the adult ants and the developing larvae, effectively converting otherwise unusable plant material into a digestible and highly nutritious food. The fungus garden is a miniature, living ecosystem meticulously tended by the ants with quiet dedication. Every act, from shredding leaves to producing antibiotics, is a gentle, continuous act of care, ensuring the vitality of their shared life. The fungus's metabolic flexibility is a silent, responsive intelligence adapting to the ants' offerings, ensuring a resilient food supply. This constant, gentle tending creates a profound sense of peace and order, a continuous dance of life and sustenance, a quiet partnership that underscores the intricate balance of the subterranean world. Chapter 7: A Symphony of Roles, the Quiet Dance of the Colony. Within the vast subterranean metropolis, a quiet dance of specialized purpose unfolds, orchestrated by an intricate division of labor. This is not a chaotic scramble for resources or a rigid hierarchy imposed from above, but an elegant and highly efficient system where every individual contributes to the collective well-being. The leafcutter ant colony operates under a highly sophisticated social structure where individuals are broadly classified as either reproductive, the queen, or workers. The worker caste itself is astonishingly diverse, distinguished by as many as 12 distinct worker morphs in some species, showcasing an astounding level of physical differentiation and specialization within a single colony. This remarkable polymorphism, with ants varying significantly in size and form, is a natural specialization, ensuring that every task, from the most delicate and precise to the most strenuous and dangerous, is performed with gentle efficiency and remarkable precision. Each ant, regardless of its minute size or imposing presence, plays a vital, specific role, a testament to their highly organized, yet quietly flowing society. This intricate organization is so advanced that it is often regarded as one of the most complex animal societies on Earth, perhaps second only to humans in its intricate coordination and agricultural innovation. The colony functions as a living mosaic, a superorganism where each ant's unique form and specialized function contribute seamlessly to the whole, creating a unified and incredibly effective entity. This biological marvel allows for an extraordinary range of tasks to be performed simultaneously and efficiently, optimizing resource allocation, defense strategies, and the overall maintenance of their subterranean empire. From the smallest minim, barely perceptible to the human eye, to the largest soldier, a formidable presence, a tireless procession of specialized workers ensures the colony's continuous operation, a perpetual motion machine of living parts, each working in silent harmony. The specific tasks assigned to different worker sizes maximize the energy efficiency and productivity of the colony, demonstrating an evolutionary pinnacle of cooperative living. The smallest and often overlooked members of this grand symphony are the minims. These delicate ants, with head widths typically ranging from zero point 0.9 to 1.1 millimeters, are the gentle caretakers and quiet maintenance crew within the heart of the nest. Their tiny mandibles are perfectly suited for performing the most intricate and precise tasks essential for the colony's survival. Within the nurturing confines of the chambers, minims are meticulously involved in brood care, tending to the developing eggs, larvae, and pupae with unparalleled dedication. They constantly clean the surfaces of the delicate brood, remove any debris, and gently transport them to chambers with optimal temperature and humidity, ensuring their healthy development. They ensure the eggs are not contaminated and that the vulnerable larvae are fed and kept safe. This constant gentle attention is vital for the growth of the next generation of workers. Beyond nurturing the next generation, minims are also crucial to the fungus garden itself, acting as its primary gardeners. They are responsible for the meticulous shredding of the fresh leaf material brought in by larger foragers, breaking it down into an incredibly fine pulp, which is the perfect substrate for the fungus to grow on. This microscopic gardening work requires immense precision and tireless effort. To this substrate, they meticulously add fecal droplets, which contain vital enzymes and nitrogen critical for the fungus's digestion and growth. They then carefully mold these processed materials into moist pellets and carefully plant fungal hyphae onto the newly constructed surfaces. Perhaps their most critical role in the garden is sanitation. Minims constantly patrol the garden, plucking out spores and hyphae of foreign molds, especially parasitic fungi like Escavopsis, which are highly virulent and can quickly devastate an entire ant garden. They also groom contaminated body areas of other ants and themselves, removing any spores that might be clinging to exoskeletons. This continuous quiet battle against pathogens is a critical sanitation role that safeguards the colony's food supply. Furthermore, minims also engage in general internal nest maintenance, continuously cleaning tunnels, removing waste materials, and performing minor excavations to keep the pathways clear and the environment pristine. Some minims even specialize exclusively as garbage collectors, isolating themselves from the main colony and the fungus garden in dedicated waste chambers to prevent any potential disease transmission, a remarkable adaptation for hygiene. Beyond their internal domestic roles, minims also serve as minuscule guardians for the colony's foraging expeditions above ground, an act of surprising courage and crucial defense. When larger worker ants venture out to cut and transport leaves, they are at significant risk of attack by parasitic flies and wasps, particularly phorid flies. These tiny, insidious parasitoids attempt to lay eggs into the soft intersegmental membranes or crevices of the worker ants' heads. If successful, the phorid larvae can then burrow into the ant's head, eventually leading to its decapitation and death. The minims, by their vigilant presence and precise actions, act as a living, tiny shield. They embark on a perilous journey atop the freshly cut leaves, carried by the larger media and minor workers, riding like tiny sentinels on a green shield. Their role is to actively ward off these aerial predators, swatting them away, or even plucking them off if they land. This is a quiet act of unwavering vigilance, a tiny shield against unseen dangers, demonstrating a selfless dedication to the colony's defense, even putting their own small lives at risk on the exposed surface of a leaf. Their presence significantly reduces the mortality rate of the larger vital foragers, highlighting the profound interdependence between the different worker castes and the quiet ingenuity of their defense strategies. The minim, despite its size, is a truly indispensable cog in the complex machinery of the leafcutter ant metropolis, a testament to the power of specialized, gentle work that ensures the smooth functioning and survival of the entire colony. Chapter 8: The Quiet Harmony of Forms. Castes and their purpose. Building upon the delicate internal work of the minims, the medium-sized ants, known as minors and mediae, form the backbone of the colony's external operations and major internal construction. These are the tireless foragers and excavators, whose robust forms are perfectly suited for the demanding tasks of gathering resources and continuously expanding the subterranean city. Minims, slightly larger than minims, typically have head widths ranging from 1.8 to 2.2 millimeters. They are often the first line of defense in and around foraging columns, patrolling the surrounding terrain and vigorously attacking any enemies that threaten the foraging lines. Media are the generalized foragers, larger still, with head widths typically from 3.7 to 3.9 millimeters, though the range for general foragers can extend from 1.6 to 5.0 millimeters, encompassing both minor and media sizes. These ants represent the most powerful and prolific foragers among the worker castes, responsible for cutting and transporting the bulk of the leaves. The foraging process itself is a marvel of coordination and endurance, a ballet of efficiency unfolding across the forest floor. Once a suitable plant is located, often guided by pheromone trails laid by scout ants, the minor and media ants use their powerful serrated mandibles to snip off pieces of leaves, which are typically 1 to 2 millimeters across. These fragments are often in perfectly semicircular shapes, each weighing many times their own body mass. They then hoist these fragments high above their heads, creating the iconic parasol image, and begin their arduous journey back to the nest. This is a quiet display of immense strength and unwavering determination. These ants are legendary for their carrying capacity. They can carry loads weighing up to 50 times their own body weight, an extraordinary feat of strength. While some scientific studies indicate an average maximal load for Atta species is closer to 8.78 times their body mass, Irrespective of their specific size, this still represents incredible biomechanical efficiency. They move their colossal burdens with surprising ease and steady purpose across the forest floor and into the depths of their home, traversing established foraging trails that can extend 90 meters, 300 feet or more from the main nest. These trails are worn smooth and clear by countless journeys, acting as ant highways that streamline the flow of material. The sheer volume of vegetation they transport is staggering. Collectively, leafcutter ants consume more vegetation than any other animal group in their habitat, stripping as much as 17% of the leaf biomass from plants in their ecosystem and able to clear entire trees in under a day. This makes them significant agents of nutrient cycling and disturbance in rainforest ecosystems. In addition to their ceaseless foraging, these medium-sized workers are also the colony's primary excavators, continuously expanding and maintaining the vast underground network. Their digging methods, involving the precise formation and transport of soil pellets, are both meticulous and efficient, ensuring the structural integrity of the complex chambers and tunnels. They tirelessly contribute to the construction of new fungus gardens, specialized waste chambers, and intricate ventilation shafts, constantly adapting the subterranean architecture to the growing needs of the colony and maintaining its optimal internal environment. Finally, at the apex of the worker caste in terms of size and raw power are the soldiers, also known as majors or dinergates. These are the largest of the worker morphs, sometimes reaching up to 13 millimeters in total body length. Some species, like Adela evigata, can produce even larger soldiers, reaching up to 16 millimeters in length, and possessing imposing head widths of 7 millimeters, making them truly formidable creatures. Soldiers are primarily dedicated to protecting the nest, acting as the colony's formidable military force. They stand as quiet, unwavering sentinels at the nest entrances and along the foraging trails, ready to defend the colony from any perceived threat. Their massive, powerful jaws are their primary weapon, designed for crushing and shearing. Their bite force, measured at 800 millinewtons, is an astonishing 2,600 times their own body weight, a force capable of crushing the exoskeletons of intruding insects or even piercing human skin. There are numerous accounts of leafcutter ant soldiers inflicting painful bites that can slice through flesh to the bone in a matter of seconds, highlighting their immense power despite their relatively small size. While their main role is defense against larger predators such as armadillos, anteaters, birds, and rival ant species that might attempt to raid the precious fungus gardens, recent evidence indicates these majors also participate in other, less combative activities. They assist in clearing large debris, such as fallen twigs or stones from the main foraging trails that might impede traffic flow, and occasionally help in carrying bulky items back to the nest that are simply too large for the smaller castes, showcasing their versatility and contributing their immense strength where needed. Their imposing size and formidable mandibles serve as a silent deterrent to potential predators or rival ant species, a living wall of defense for the entire colony. The caste system within a leafcutter ant colony is not a rigid, unyielding hierarchy in the human sense, but a quiet harmony of specialized purpose. It is a living mosaic where each size and role contributes seamlessly and indispensably to the whole. The minim's delicate guardianship, the minor and media's tireless foraging and excavation, and the major's quiet strength and formidable defense are all equally vital, demonstrating a profound, peaceful interdependence where form perfectly follows function. This intricate design ensures the colony's continuous, gentle operation, a wondrous example of nature's quiet artistry, a testament to the power of distributed intelligence and cooperation that allows millions of individuals to function as a single, incredibly efficient entity. This remarkable division of labor also extends to the very rhythm of their day, a subtle interplay of individual work cycles that maximizes efficiency around the clock. The colony as a whole exhibits a continuous, unceasing nature in its collective effort, a quiet dedication that never truly rests. While the colony as a whole may have an overall nocturnal rhythm, with higher ant flow and activity occurring at night when temperatures are cooler and humidity higher, individual ants demonstrate differential foraging time preference. This means that certain worker castes or subsets of workers are more active during specific periods. For example, some ants are predominantly nocturnal ants, generally smaller individuals, and those less engaged in the demanding task of leaf transportation, preferring the cooler, darker hours for their specific duties, like internal nest work or fine leaf cutting. Conversely, diurnal ants are typically bigger and are more engaged in the arduous task of leaf carriage, venturing out during the brighter, warmer hours of the day. This subtle temporal division of labor allows for continuous colony activity, meaning the work never truly stops. There is always a segment of the population engaged in productive labor. This quiet, unceasing dedication to the colony's needs, adapting to the gentle shifts of day and night, ensures maximum efficiency and constant provisioning of the fungus gardens. The subtle interplay of individual rhythms within the larger collective rhythm creates a gentle ebb and flow of tireless work, a continuous pulse of activity that ensures the colony's prosperity without frantic urgency. This quiet, persistent effort is a testament to their deep collective dedication, a harmonious dance with the passage of time, ensuring that the work of the metropolis continues, always a seamless integration of individual purpose within a grand collective design.